Hey guys, this is Stanton here. We are jumping to topic 16, which are operations on polynomials. This video is going to go through both student activity sheet 1 and 2 at the same time. So on this first set, we have the Bradley family. They just built a house in a new subdivision. They have already purchased a 100-foot by 80-foot lot in which they will construct their new home. So with this, you can see the layout here. They learned that there's some guidelines that they have to follow here. The subdivision says that first, the builder must have a 10-foot easement on either side of the house to accommodate the placement for utilities, power lines, and so forth. So that means essentially what that means, guys, is you can't take your house right up to the side. Okay. The second is that the builder must locate the house at least 25 feet back from the front of the lot to allow for place of sidewalks, street lights, landscaping. Typically, you'll see like maybe if they want to expand the road, they get 25 feet that they could essentially come onto your property. I know, crazy because you think you're buying all this land. In reality, you're not. That's real life, guys. I know lots of subdivisions have 10-foot easements at the front and the back and whatnot on the side. So let's go ahead and look through this. Question 1 states, what are the area of Bradley's lot given that the dimensions are 80 by 100? Well, the first thing to recall, guys, is that area is the length times the width. So let's just look at his 80 by 100 foot thing. So we're going to say 80 feet times 100 feet to get 8,000 square feet. Question 2. Find the area of the Bradley's lot that can actually be used for construction. So with this, guys, what that means is we have to go through. They said that they were going to take off 10 feet on both sides of the house for power lines. So we have the 100-foot length right here. And we're going to take off 10 feet here and take off 10 feet here. So we're taking off 20 feet total to get an 80-foot length. And then the width, they said that we have to take 25 feet off the front right here. So we did 80 minus 25 to get 55 feet. Now we're going to go ahead and multiply those together, and we get 4,400 square feet. They almost cut our property in half that we could actually build on. Next thing, guys, that just gets us thinking about multiplying here. Now what we want to do is go through, introduce some of the terms for you. Okay, we're going to go ahead and skip that. The next question is, what is a polynomial? Well, with that, guys, it's a lot of words here. A polynomial is an algebraic expression that is the sum of terms that are numbers, variables, or the products of numbers and variables with exponents that are not negative integers. Now, for all of that, let's just break it down. A polynomial can be 5x, 100 minus x, 3x plus 4, 2x to the third y minus 3xy, or x squared minus 4x plus 5, okay? As long as we are adding or subtracting numbers and variables, you're good with that. Going on. Okay, let's go ahead and look at student activity sheet 2. So on this, guys, we are going to learn how to multiply. Some big things before we go through and actually multiply this. I'm going to go ahead and get rid of that here. And we're going to get rid of this. Nope. Okay, let's go through some of this. The first thing that they ask us here, this goes back to the Bradley's house. So these are the blueprints for inside of their house. They want to know, what does the X represent? Well, the X is the length added to original dimensions of the house. So for example, this length over here of this bedroom is 13 feet. The width of this bedroom is X plus 12 feet. What we know is we know that this full amount is 8 feet and X plus 10 feet. It's an unknown amount that they're going to take away or add to. What are terms of a polynomial? Terms are just simply parts of the polynomial that are numbers, variables, or products with positive exponents. For example, 2x is a term. 5 is a term. 3y squared. All of that together is a term. So let's just talk about the different types of polynomials here. When we have a polynomial with one term, meaning one whole set, that's what we call a monomial. Mono means one, a polynomial with one term. So here's an example of it. You may say, Mrs. Stanton, that's 3 terms. No. When it's multiplied together, that's one whole term. A binomial with 2 terms, a polynomial with 2 terms is called a binomial. That's like a bicycle. It has 2 wheels. So here we have 1 term, 2 terms. And then a trinomial, that's like a tricycle. Tricycles have 3 wheels. Well, a trinomial is a polynomial with 3 terms. So we've got 1, 2, 3. And again, these are just examples. They can come in many shapes or forms. Okay. The next thing we need to know is what is the degree? What is the degree of a monomial? Okay, so when we're dealing with just a single term right here, just a single term, the degree is the sum of all exponents with each variable in the monomial. So example, we have a 1-term polynomial here, a monomial. What is the degree of the variables? Well, I have a degree 2 and a degree 4. So 2 plus 4 equals 6. The degree is 6. What is the degree of a polynomial? How does this differ? Now remember, a polynomial is several different monomials put together in one. So the degree of a polynomial is the same as the highest degree monomial in the expression. So for example, when I look up here, this monomial is 2 plus 1, so that's 3. This one's 1, and this is none. So what is the degree of this polynomial? The highest degree is 3, so the degree is 3. So another example of that, what is the degree of this? We've got a degree of 4, a degree of 1, and a degree of none. So my highest degree is 4. The degree of the polynomial is 4. So let's just go through and fill out this table here. With this, we have 2 terms, so it's a binomial. What is the degree? 2 and 0, so the biggest degree is 2. 1, 2, 3, so it's a trinomial. Let's look at my degrees. I got 3, I got 2, I got 1. My biggest degree is 3, so it's a 3rd degree. My monomial. Again, let's add up the exponents. I got 2, I got 1, I got 1 to make it 4. So my monomial has a bigger degree than all of my other polynomials. Okay. With this one, they want us to use the distributive property. Guys, you know what the distributive property is here. If I said 5 times 2x plus 3, we've been doing this a long time. Distribute means to multiply it. So we'd have 5 times 2x plus 5 times 3 to get 10x plus 15. We've been doing that. I'm going to go ahead and skip number 9 and skip number 10. Okay. I want to look at number 11 because I want you to see it on here. So we're going to use the distributive property to simplify these 2 things together. The distributive property, guys, what that means is that everything in this first set of parentheses has to multiply to everything in the second set of parentheses. The distributive property, we may use the word FOIL. You may hear your teachers use this. Okay. FOIL, what it stands for is my first terms get multiplied. Okay, so I'm going to say 3x times 2x to get 6x squared. The O stands for the outside terms to get multiplied together. So that's going to be 3x times 2 to get 6x. And then we're going to use the I stands for the inside terms. So I'm going to multiply my 2 little insides together. That's going to be negative 2 times 2x to give me negative 4x. And then lastly, the L, which stands for the last terms. The last terms in each set get multiplied to each other. So the negative 2 times the positive 2 to get a negative 4. We then have to combine those like terms here in the middle, the 6x minus 4x to get 2x. And that's it. We cannot put those any further because they are not like terms. But now I'm going to show you guys a different way to do this problem, and that's what we call the box method. This method, because up here we may forget some things or what went where, the box method is actually fairly simple. It's going to guarantee that we multiply everything to everything, okay? And all we do is we make a nice box. Now it does not matter what set goes on which side, as long as this entire set goes either here or here. You can't mix and match, okay? So I put my 3x minus 2 on top, and I put my 2x plus 2 on the side. And all I did here was I went through and I said, in this first box, what comes together? This is 3x times 2x, and that gave me 6x squared. Negative 2 times 2x came together right here, so I got negative 4x. 2 times 3x gives me a positive 6x. And lastly, negative 2 times positive 2 is negative 4. Here's the thing. We get a nice diagonal here. The diagonal, circle it, make the peanut. That is going to be your like term. We end up with 6x squared. 6 minus 4 gives me plus 2x, and then bring out the minus 4. Okay, so you can see between the two, they're the same exact ways of doing things, and you still get the same answer. We're going to skip number 13 and 14a. Let's go ahead and do the box method on this one. So again, I got 2x minus 3 on top, and I got x plus 1 on the side. Go through, I get 2x squared minus 3x plus 2x minus 3. Combine the diagonal, 2 minus 3 or negative 3 plus 2, and I get negative 1x in the middle. Okay, showing you the same exact way. First, outer, inner, last. Okay, again, when I look at these, same exact results. It's just two separate ways of getting the job done. So on this problem, I'm going to show you, it says to use any method that you want. First, I'm going to show you guys the box method, okay? So we have 3x plus 23 being multiplied to 2x plus 17. So with this, I'm going to start in this first box here. 3x times 2x gives me 6x squared. 23 times 2 gives me 46x. 3x times 17 gives me 51x. And then 23 times 17 gives me 391. We're going to combine the diagonal here, and I get 6x squared. And then 46 plus 51 gives me a positive 97x. And then bring down that plus 391 feet squared. Okay. Using our FOIL or distributive property, it helps if I write the problem out here. We got 3x plus 23 times 2x plus 17. So with this, I'm going to show you guys. We're going to do first to get 6x squared. My two outside terms, 3x times 17 to get a positive 51x. My two inside terms, 23 times 2x to give me 46x. And then my last terms, 23 times 17 to give me 391. Combine like terms in the center there, and I end up with the same answer of 6x squared plus 97x plus 391 feet squared. Down here, They want us to use the box method to find the volume of a rectangular prism with a base area of this and a height of x plus 3. Well, the big thing to know about volume of a rectangular prism, that is the area of our base times the height. Well, they gave us both of those numbers, okay? So we just have to multiply these together. We are going to do the same thing as the box method, but instead of just two terms, we have x squared plus 5x plus 4. We have three terms. So my box is going to be a 3 by 2. And right up here, x times x squared is x to the third plus 5x squared plus 4x. Come down here, I get a 3x squared plus 15x plus 12. And just like we did before, check your diagonals. My squareds come together, so I have x to the third plus 8x squared. 15x plus 4x gives me a plus 19x. And then lastly, a plus 12 square inches. And then lastly, number 17 here. Same type of thing. I went ahead and showed you guys this one because it is a trinomial to a trinomial. Again, all this does is it just adds a third box on each side. Again, you're going to go through multiply 2x to the fourth, 10x to the third, 8x squared. 1x to the third, 5x squared, 4x, negative 2x squared, negative 10x, negative 8. Your diagonals, just like before, can be combined, and you can check them. They're like terms. My cubes go together, my squareds to go together, and my single terms go together there. And you end up with an answer of 2x to the fourth plus 11x to the third plus x squared minus 6x minus 8. And then you'll go ahead and do the rest of those problems with your teacher.